Now we are going to look into safety tasks, and this video is going to be about safety in general. And we are just going to look at the figures in our compendium and scroll down the figures and talk a little about the figures and the information related to those. So if we now have a look up here. This is the compendium. So what we're going to look at is safety. And yeah, here is important. It's under no circumstance allowed to compromise the safety of humans. Under no circumstances. So that has to do with personnel safety, equipment and environmental safety. So we don't want to destroy the environment or the equipment we are set to control in the process. As an example too. And then we have this hazardous area. We don't want explosion and stuff. So the equipment you use should not cause any problems. For instance, in EX zones and stuff like that. Safety task handling. So what we want is intrinsically safe equipment. The equipment, if you buy equipment, it shouldn't be able to destroy itself during normal use. So it's the supplier's responsibility to assure that it's not destroyed. So when we have safety, we have mechanical safety barriers, but that's not a part of this compendium. That's mechanical, let's say fencing and so on. But yellow is the color for safety. Then we have interlocks. So an interlock here is a valve, prevents a pump from starting, because if the pump starts, it can destroy the valve or just flanges or whatever, and damage to the pipe. And this, let's say the pump itself can't destroy itself and so on. No, the valve itself and the pump itself, but it's the interaction between this that can cause damage, for instance, to the piping and so on. Then you can use an interlock. So if the valve is open, it's possible to start the motor. Here is shown a traditional motor starter with a contactor or something. Then we have emergency stop. If dangerous situation can occur, the operator can intervene by activating an emergency stop, or someone can intervene and stop the motor. And also here is a safety breaker with a padlock on, which is tag out and lock out. So you can lock it with a padlock. You have a personal lock. So if you're doing maintenance here on the system, you can make sure that the pump doesn't start. It's not possible to transfer energy to the pump, even if there's no emergency stop, no interlock, and the control system says it should start. So we have electronic equipment that is used to make processes or secure processes. So it's electronic PLCs mainly, but it can be other systems too. Triple modular systems or special safety PLCs. And specification for safe action, especially in large systems, can be done via cause and effect and a cause and effect matrix. So as an example here, if the input 2 is active, then the output 7 and 9 is set to true or false, depending on what you want to do. Start something or stop something. And here we have 3 other causes that's causing an output to be set or reset. And here we can also do voting and see if 2 of these indicates a fault, we do a safety action. Cause and effect matrix. And there are some suppliers, Siemens for instance, PCS7, they have a cause and effect engineering tools. So you can actually engineer cause and effect matrix. Other suppliers do so too. And then we've got something in series with emergency stop that's called emergency shutdown by some electronic system or safety system. And if there is something that should cause the pump to stop, okay, this breaker here is open, a switch is open, and the pump stops. assuming here the safe state is a stop pump. So that's, let's say, passive safety. So we are stopping equipment. So that's an emergency shutdown. But then we have active safety or emergency start. For instance, here we can use smoke or fire. In a high voltage switchboard, we detect smoke, and then we can start a pump that just injects foam into the switchboard or something like that to save the system. So this is active safety. And then there's the sensor and actuators. There are special requirements for these, and here is some short on these. And the next is what we call technical safety. So that's going to be a separate video. So what we have looked at is safety in general. So what we looked at is, let's say, if we walk through it fast here, we looked at mechanical barriers. This under no circumstances allowed to compromise human safety, injure or kill people. Of course, we need to avoid that. Then we have safety for equipment and environment, and we have this with hazardous area. Also not much about that, but that needs special equipment. And then there's a handling of safety task, intrinsic safe equipment, mechanical safety barriers, interlocks, emergency stop, electronic equipment, and so on, and the cause and effect matrix. So that was a quick introduction. Of course, we're just scratching the surface here. Safety is a separate discipline in safety and automation. We are scratching the surface.